So thank you. I mean, we have seen quite a diverse catalog of topics. So let me read the titles again of the presentation. The first presentation was data-driven participatory decision model proposal in the context of urban vibrancy. The second one, a machine learning approach to translate GANs-generated graph representations into conceptual massing models. Third one, AI-informed intelligence and aggregation for solar design in the built environment. The fourth one, big data versus smart data on the generation of floor plan with deep learning. And the last one, daylight and energy consumption assessment of a school building through a multi-objective optimization and clustering. Clustering technique, sorry. I mean, what we have here is a wide catalog of approaches to take advantage of existing technology. Is yesterday in our conversation with the keynote, Greg Lin, at the very end, we were, asking about his thoughts about the notion of early adopters. I mean, obviously, everybody here is an early adopter of those techniques that are under development. We know there is a lot of challenges and it's very promising. And I would like to invite you to discuss about the challenge, because I have a long list here, right? This is an open question, then we can dive into the particular topics of each one. But if I can put a list together, for example, first article, I have questions about the data validation, the data we use, right? The data we survey from reality or from data sets. I mean, what is the validity of that data? Can we trust in that data? How clean is that data? Is complete that data, right? There is an issue or a big question, not an issue, a big challenge and question regarding the validation of the input data, right? Another challenge, I mean, I see is one other question is the error, the percentage of error in the prediction, right? Or do we have enough input parameters to describe the phenomenon we are talking about, right? Computational intensity, right? There is this paradox. In order to predict in a matter of seconds, I need to invest 400 hours to do that, right? There is a very interesting paradox there. So if you have so much information, maybe you don't need to do that, right? Data volume, right? Time of training, right? Post-processing the results. So making sense of the data. We have seen this technique of clustering in the last presentation, trying to make sense of the data. In my experience, what we do is we use another technique that is in the same direction, is sensitivity analysis, which is looking for the same thing. What is the correlation between inputs and output? There is any correlation, right? If there is any, what is the reason? I don't know. I mean, there is a wide catalog of challenges. So I would like to hear from the authors. What are your thoughts about this? I mean, what are the challenge you're facing, and how do you see the next steps, right? You can raise your hand and start. Okay, Dulce, are you going to start, right?
Yes, okay. In terms of the validation of the input data, and I mean the collection of the big volume of data about the places, actually it was challenging for me to cope with this amount of the data, because since they are user driven, it takes so much time to standardize the data according to making them in a data set. And then I actually validate the data sets with the real data, the administrative map results. And that's why I compare them about the place information. So, and actually the Google Places API results mainly was validated. I mean, that was correct with the same place in the map, because I observe it in my site observations when I visited there as well. And I also double check it some of them maybe through the Google Maps result, the Maps result, not the API results, but some of them were wrongly checked, and I have to eliminate them. So yes, that it takes lots of process for me, but lots of I mean that was time and labor intensity work to do. And you are right, maybe I have to do a sensitivity analysis as well. This was my first experiments with data, and how can I actually process data, how can I inform how can I generate information using that data. But the sensitivity analysis and actually the validation of the data was also important concerns that I will take into consideration. And you mean the percentages of the error, but if these percentages coming from the surveys, actually the number of the participants was so limited. So I both increased my sampling sizes, I mean the analysis of the units from neighborhood to the grid scale to increase the sampling. And I also increased this participant number. This was the first initial results of the survey. That's why I mean the percentage of error was bigger than I thought. I think that if I increase both the sampling size, and that will increase the prediction capability of the learning algorithm as well, since the sampling size getting bigger. And if I ask more respondents, more participants this survey, the evaluation result will be changed accordingly in parallel. And I think the error percentage will decrease more, I suppose. But thank you for these. For your critics.
May I speak?
Yeah, sure, please.
I think what Gus is saying, like her challenge is like to get participants to evaluate something. Like we have to trust nowadays on the available data we have, and sometimes we need some type of data that is not available. For example, in her case, she needed participants to evaluate and decrease the error rate. In my case, I think it's more about a process that was not tried at this scale before, but I think it returns guidelines for how should we train models like this. You know, we don't need to set up like for this specific algorithm, right? Because if we get other algorithms like graph neural networks or natural language processing, we're going to have other types of performances, and the algorithm works in a different way. So it's specifically for pix-to-pix. If we're going to build a data set, for example, of Brazilian houses, of houses from a specific city, we can already explore this type of technology without getting too much resources. So I think it's the opposite from her case. We're trying to make the training faster, and in her case, for her predictions to get better, she needs more participants. All right, so there's like a contrast between one another.
That's right. Anybody?
Hi.
Hi.
Maybe also thank you, Gilles and Ricardo, for an insight to the challenge. I think one of the challenge that probably goes through all the project is how one algorithm bridges another one. So like the translation between data, which is also exactly what our team is facing, because we're going from Houdini, Grasshopper to a custom Python framework in Visual Studio. And then some algorithms, they understand 2D data, some algorithms, they understand array and stuff like that, but they're all artificial intelligence. So how do we actually make the data not just as an image, but also as a set of instruction that can help different algorithms to learn between one another? And I'm actually really happy to see that the first paper go from HowScan to Blender. So it's like between open source, and also at the same time, the challenge of how do you actually translate between 2D and 3D as opposed to just a stacking mechanism. Like, can we have line tracing point or teaching like a pigment neural network to actually, trace itself around a floor plan? and thus be able to understand other aspects of the impact of what we're generating. I think that should also be an interesting discussion.
Yes, another thing maybe is really relevant is related with the lack of three-dimensionality that we are facing with this techniques. As we are just starting to understand the real challenges in this in all these ideas that we are running now. Well, architecture is based on space, three-dimensional space, and till now we are just trying to understand how to translate this to the information. For instance, pick to fix the things that we are working with in our case, how to use pix to pix as a translation tool from 3D from 3D to 2D and then to 3D again. So it's something super challenging that in a way maybe in the near future we are going to develop to be developing a proper 3D-dimensional machine learning system instead of these hybridizations that we are doing now. That's something that as early adopters we are facing all these issues, but it's really interesting because we are pushing in time by time the boundaries of what we are doing.
Yeah, that's right. I mean, sometimes we develop something. I mean, I'm working on. So let me reintroduce myself. I'm Marcelo Bernal. I'm the vice president of Sigradi, but I'm also the director of the design process lab at Perkins and Will. And we in the professional practice, we don't have room for too much percentage of error. We need to be very effective. So the kind of things we're doing are more in the problems we already know. We have a well-described set of problems. For example, energy is the easiest, most difficult thing you can do. Why? Because there is tons of parameters, but we know all of them. We have been working as a community in that problem for 25 years. So the level of prediction we have there is very precise, it's acceptable, but however in others, even something like daylight, in daylight we are having issues because you have the typical window to wall ratio. Some of you are working in that area, but then in order to define the actual shape of the window, to the right, to the left, up, down, the center is a longer one, it's a vertical one. You need more descriptors, more parameters. So then you're increasing the number of parameters and you get into this crazy paradox. It's so large, right? Because you need so much description to increase the prediction that in some point you need to stop. So we, in early design stages, we're accepting sometimes 10% of error, even 15, right? Which is, in a statistic, is totally unacceptable. But for us, it's good to go. Why? Because there is a balance, right? In others, 2%, 5%, which is good, right? In a matter of seconds with a small sample. But in others, it's crazy. I was in a conference like 2 years ago, Advancing Computational Design, a professional conference, very interesting. And some researchers from a Japanese company, I don't remember the name right now, they were working on CFD, using machine learning to predict CFD. CFD, computer fluid dynamics, takes a while for one iteration, a couple of hours, maybe a day, right, to converge. So using machine learning to accelerate, to speed up that process sounds very promising, right? Yeah, the reported error was around 30%, which means totally useless, right? Totally useless as a prediction. But that was 2 years ago. I would like to know where those guys are, right? I see this army of people exploring, right? Trying to understand every problem, because we need to understand the specific problem itself, right? CFD is one type of problem, right? Dealing with people, another problem. Energy, another problem. So, and each problem and each algorithm is a kind of two-dimensional metric that is very interesting to explore, right? So those are my thoughts. I mean, at least my personal experience is pretty challenging. So I would like to ask you, unless you have another comment, to move towards the education, because I know some of you are educators, what have been your experience in that area, teaching, sharing with the new generation of designers and these kind of techniques? You can come back to the previous question if you want.
Well, maybe we can talk a little bit from the bottom of what is happening here, or really with the machine learning and all these implementations, including as well how we are linking now this with well, using some other tools like evolutionary solvers, as well with Fusion 360 and environment with Autodesk Clouds, etc. And as for what one hand, on the other hand, we are working with more the classical way, let's say, with coding and all these other things. And in a way, this is something super challenging, because year by year we are reevaluating what we are doing in terms of, just in case, when the last year we are starting with this idea of okay, let's try to mix to introduce these generative solvers with as an open class. Let's see if this works, and then it's working. So let's try to introduce something new now. But then it's something that we were talking yesterday about that in one of the masters in which I'm teaching with the engineering and architectural design. Well, this is the chance that we have to test few things, and then let's evaluate what is happening with these things. So it's in the academia, which is we can in a way we can find this degree of freedom for us researchers, as educators, as you said, because in the professional practice it's slightly impossible to have these opportunities. So, and as well, the students are really responsive about these new things that are coming year by year, and in a way we are kind of we are working together with the students. So it's not about just us working in complete independent way. We are being really we are working as a team with the guys at the same time. So every year we are really impressed about the results that are coming, because every year is something that is something that is let's say funded by the previous year. So it's something that is growing and growing and growing. And maybe, as you said as well, maybe this idea of being working with artificial intelligence and all these machine learning processes is going to be then maybe something so as business as usual. Now it's something quite new, but 5 years ago was something completely, let's say, something unique. Now all of us we are working in a way with this, but then it's going to be good. Something, I mean, let's say part of the industry, something standard.
Yeah. Any other comments in that matter? You can raise your hand. I think I have some question in the chat. No, it's not a question.
I would like
to... Daniel. Okay.
Hello, Marcel. How are you?
Hola.
Everything fine?
Everything fine. I've seen you in many presentations.
Yes.
You're always in the.
Yeah.
You're very active.
Yes.
Yep. Trying to look for a lot of things. I would like to ask to all the participants if they think that machine learning in the result that you are achieving, that it's possible to achieve some consensus in some kind of parameters and some kind of procedures in order to establish standard methods to achieve some predictions, some valid predictions. Let's say, do you think that, according to your experience, that is possible to converge to a kind of standard method or standard methods in order to achieve in an efficient manner the best results that is that is after all the purpose or the goal of the machine learning process is trying to achieve better results in the performance of the process. So do you think that it's possible to according to your experiences to achieve a standard method, standard parameters for some kind of problems that are going to facilitate to turn more easy our future tasks utilizing the machine learning approach? It is a generic question. I'm not specifying to some panelists in concrete, but it is an open question.
May I answer?
Yeah, please.
I think it's a difficult question to answer because it depends on what kind of algorithm we're using and how much parameters we have. So, for example, in machine learning, we have some problems like underfitting and overfitting, and like underfitting is when you show only few data samples and the machine is not able to understand. Or overfitting is when you train so hard and you have so much data that the machine cannot generalize a type of information to make a certain prediction. And we have another phenomenon called the curse of dimensionality. That's like when the dimensions of the data points are so high dimensional that it cannot be synthesized into one prediction, right? Or there's not a single final solution. And I think it depends on the challenge we are approaching. If it's like we're trying to predict the solar performance, or if we're trying to predict the spatial organization of a floor plan, if we're trying to predict, I don't know, the workflow in a city, I think the answer depends on the amount of parameters we have. I think that's it.
Just to jump in, I think a more personal comment is that we should thank the sky that there are no standard way, or else everything would have been automated by machines by now. And because it's non-standard architecture, that's why creativity is still relevant. Architects are still relevant. And I don't think in a short amount of time, machines will be taking over our jobs, as many people are afraid. And I think that goes back to the education question. I don't think it's so much about just educating humans. It's more, I think all of our works are actually a collective work in collectively teaching machine, which we can all see that it's very single task. It's kind of dumb. And that moves us to the idea of distributed learning networks. Like if the next global challenge is perhaps, is there a way that we can all continuously be training neural networks all together, which right now with supervised learning is super difficult because we have to delete the data point and retrain the entire model. So it's almost like a vision where there should be a way to continuously mine real-time data onto a common database where it will be fitting the machine. And then maybe also BIM with Newtonian physics can evaluate what the neural network has output and real-time fit it back to it, which our workshop this time at Sigradi was trying to attempt at breaching that. So Victor?
Yeah, anybody else want to comment on that? I can share my experiences. We developed in-house a system for energy analysis, and for 2 years we were working on the data model. What are the inputs? What are the assumptions? So basically, you input geographic locations, some general description of the building, and the system makes a lot of assumptions based on code, right? And we have that standard set of data, and that is helping us to speed up that process. But there is no machine learning that works in the cloud, right? It runs pretty fast and runs everything. It's like a gun machine, right? Very brutal, right? Just computational muscle. But now we are combining that, trying to use that to generate the data set really fast in order to use some of the different algorithms that are out there to do that. But that problem is a well-described problem. You can standardize that problem, but still it's a schema you can extend. So for me, answering your or addressing the question about standardization is I believe in data models that can be potentially standardized but extensible as well, Daniel. I mean, I believe they should be flexible enough to accommodate the complexity of the architecture, because not for some reason people like to buy the same car. They don't have a problem, but everybody wants that unique building, right? But I think we need to work probably in the extensibility of those models, but we don't have the model yet. I mean, and different areas is totally different what the type of the model you need to use. And some of you were commenting that depending on the problem is the algorithm you use. We have been using some of them for just to validation of the size of our data sample. So if the algorithm is telling us with this small data sample, I can predict with an error of 5%. Okay, we don't run the machine learning. We use the small sample and we do sensitivity and we make decisions based on a small sample. And we only use the other one. I mean, it's good enough for prediction. Okay, we are good to go. We can make assumptions. Why? Because there is a general thing, at least from the profession, which is response time. You need to be fast. Design teams will make decisions with or without you. For some other reasons. So then we need to be fast, right? And this area seems to be very promising. And the standardization can help, but it depends on the problem. And in some of them, we are in baby steps, I believe, right? Anything you want to ask to the other authors about their specific work?
Can I make a provocation?
Yeah, please.
Yay, super. So thank you very much for the presentation of the papers. It was really interesting for me to watch them all, especially because what used to be a very niche or rocket science research 3 or 4 years ago is becoming very popular, and you can see people researching this topic from right now. We have south of Brazil to China to Chile to everywhere. So now that we are putting our hands on machine learning, automation, on genetic algorithms, and we are becoming very skilled on it, I think that an interesting question to ask is what are our political and economical goals behind that? Is it only increase of productivity, or is it really producing a qualitative change in the built environment, or also in the quality of life of the designer, the architect, or the builder? So this is my provocation for you guys. Thank you very much.
Thank you. I think Alberto, you have your.
Yes.
Right?
Yes. Well, in terms of provocations as well, I was just remembering that here we were talking in one of the seminars here in the Bartlett about these two ways that machine learning machine learning is built in two different ways. One way is related with data. Like here, we have several nice examples and research looking into how to work with the data in a quite serious way. But on the other side, we have the machine learning in a more being explored in a more aesthetic way. Let's say, well, playing with images, trying to create more perceptual emotions and other things. And I'm not really sure of this. In a certain point in the future development, we are going to merge these two ways in one again, because it's something super. It can be something super interesting. I'm not sure what you are thinking about that, because in our case we are working completely out of the aesthetics sometimes, But then later we must to return to that, because we need to create proposals with this in a provocative way. So it's something super challenging that I'm not sure what if you are facing something similar with your experiences.
Anybody?
Well, I can add something to the question of Victor. Maybe the ultimate goal of this, maybe the hope, I believe, like in the architecture, in the design process, there's a lot of parameters we know now, and until now, you have to try the design. You cannot experiment on it. Like you build the building and it is there for 50 years, 100 years, or even longer. So you cannot try that. If it is mistaken, you have a huge mistake there. But with machine learning, the capacity of processing capacity of the machine learning, you can process these a lot parameters, a lot data, like in a day or like in hours. So it can maybe create the ultimate design tool. Maybe it cannot design, but I think personally a machine can design with learning enough data. But let's say it can be a very good designing tool for designers.
Yeah, definitely it can be. I will address Victor provocation as well, but it's not me. I mean, it's basically transferring the experience from the pre-opening of the conference on Monday. We start early that Monday with a female panel called Experimental Media and Activism. Marcela Godoy was the moderator with 4 guests. And one of them, it was a very interesting one, but one of them, an artist, Eunsu Kang, was doing this thing. She was getting picture of people, right? And feeding the algorithm in order to predict what a person is, right? In a sort of very artistic way. And created some blur images. Some people were asked, I mean, in the survey to answer, is a male or is female? She was questioning the notion of classification, gender, and all of that. And there is two. And for example, one of the answers was people were saying, no, it looks like David Bowie or something like that. Like two people answered that. Others answer like 60% female, 30-something% male, and categories in between, including David Bowie. But what was interesting from her analysis of this, when she was presenting another example, first, there is a lot of cultural, let's say, drivers that are influencing our interpretation of the data. Okay? That was the first top point. The second point was also even further. She was predicting or classifying Asian girls, right? And when she went through the database to face recognition in airports and all of that, she realized that 70-something% of the Asian girls were smiling, right? And then she built an interpretation about what is the reason of that. And she was looking into cultural patterns, right? And the cultural patterns basically are telling in that society that girls need to smile, right? And maybe if you go to my country, you will have the macho, picture, right, in the database, right? Because it's another bias. So then what she was looking for through the data wasn't the prediction of the performance indicators. She was looking for stereotypes, for biases. That was the things she was looking for. It was, for me, it was shocking because I've been trying to describe my beloved window. I mean, what is the right parameter for my window? What is the right parameter to describe this phenomenon? But she was looking something else in that data. She was looking for those stereotypes, and I think she's addressing your question, Victor. I mean, pretty nicely. For me, it was like a revelation, that panel. So you have the chance, take a look. It's very interesting, her work from the artistic perspective. I mean, giving a completely different angle of what we're doing.
I don't think there are too much time, but maybe just
Mm-hmm.
adding on to what Marcelo was saying, which I think was pretty on point. I guess at this era, we are all trying to find a frontal line to fight. Like there are
Mhm.
so many battles, like each of us identify ourselves with one. If we don't, it's almost like we're, just irrelevant. But I guess that also, for instance, my fight with like going back to what actually characterize an intelligence. And according to Wiener and Schrodinger and all those guys, they would be saying like, information entropy increased globally, but decreases locally. But what does it mean? And I think looking at all of the work today, it inspired me that, if we're using machine learning to generate a lot of options at an almost instantaneous manner, then it's increasing information entropy globally. But then for designers to actually rationalize the decision and implement it, then our intelligence is to decrease entropy locally. So together we almost collaborate to calibrate the system, which I think it can fakely tie to a democratic digital practice in a sense that not so much as who get to do what, which is what we're fighting mostly, but what options are actually there for people to choose, which right now they're not so much, I don't know, like feminism, climate change, all this battle line are still quite limited.
Yeah, but remember, potentially there is some bias in and stereotypes in that data. Right?
Which is why overall we need to conduct that wisdom and responsibility when we do these works. So the wise ways of using technology is the overall that we need to all never forget.
Yeah.
I also want to add something to the Victor's questions. From my studies perspective, I would like to include the user dynamics when we are evaluating and while we are making decisions in terms of the urban planning, because generally this kind of planning decision was based on the building characteristics, physical attributes, and so on. And then we observe how that's gonna reflect to the user behavior or user density. So even though the challenges that the data provides us or other challenges derived from the machine learning and other artificial intelligence methods, I think benefiting this diversity of the data and including them into the decision-making process was beneficial to, for instance, in terms of the urban scale for getting an inclusive decision and for considering other layers that we generally didn't take consideration. In a way, we start to monitor and measure the user dynamics, and it makes them the ephemeral layer of the users that becomes visible. So it's also creates a potential for us for more inclusive decision making. Maybe that would be a benefit for these kind of technologies.
Yeah, a great purpose. Okay, any final comments? I think we are kind of in the time. Then we have a few minutes for break to start the new session. Any final comments? Okay, if not, what about turning on your cameras and we can have a selfie? Right? Who has the camera there and wants to participate? Okay, ready? Smile. Okay. Yeah, we are capturing. I mean, we have a small group. More people is turning on the cameras. Okay, good. It means they are listening. Okay, great. Smile. Okay, you will see that soon. And thank you, guys. It was a great session. Okay, keep doing what you're doing, right? Keep and find the battle to fight for. Okay, so we have a few more sessions, and then we will have the closing ceremony. We have new bylaws. We have been updating what our practice, because we originally had some, I mean, bylaws in like from the late 90s. We never updated them, and gradually we were changing our practice, and suddenly we realized we were kind of far apart from that. So we did a major update in order to, you know, update and also evolve and project the organization. So the voting will be during the closing ceremony, and we need your support to validate or not that work. Okay. Thank you. Bye.
Bye. Thank you very much.
Bye-bye. Thank you, guys.
Bye. See you guys.
Yeah, and talk to each other. Share emails. Bye.
Yes. Bye-bye.
Bye.
Hi, Sema.
Hello.
Hi. I'm sorry.
Yeah, what about the voice?
Hi, Sema.
Hello.
Now I can listen too. Sorry.
Great. I have a question beforehand. I think we are already in